Okay, the final question in this 2006 paper, one that you have to think about a wee bit. It starts off by talking about a company making a can in the shape of a closed cylinder. The can has to have a volume of 128 pi centimeters cubed. Now notice this is not a decimal answer, it's in terms of pi, and the radius of the can is r. So first of all, find an expression for the height h in terms of r. Well, one thing we know about this can is if it has a volume, the volume is 128 pi. But I also know that the volume of a cylinder is pi r squared times h, the height. Okay. So if we fill in what we know, 128 pi is equal to pi times r squared times h. Now we want to find what h is, so that's 128 pi divided by pi r squared is equal to h, and we can simplify that down because the pi's will cancel there, top and bottom, and we're simply left with h equal to 128 over r squared. So we have an expression for the height of the can in terms of r. Second part of this question says, show that the total surface area of the closed can may be expressed as that. Well, again, let's think of this can. It's a closed can. I know that this height here is 128 over r squared. And I know that the radius is r. We've just worked this out in part 1. To get the surface area of a tin, what we've got is the top, it's closed, so we're going to have a lid on it and we're going to have a base on it, which are both circles. So we have 2 pi r squared. But we also have this curved surface area, which actually, when you open it out, is rectangular. And when you open it out, a rectangle, the height is going to be 128 over r squared. It's this value here. But this length of the rectangle is actually the circumference of the cylinder, which is 2 pi r. And so we've got plus 2 pi r times 128 over r squared. So the area is 2 pi r squared plus, and again, the r squared will cancel with the r, and we get 256 pi over r. And just rearrange it slightly just to make it look exactly the way that they've given it. This is 256 pi r to the minus 1 plus 2 pi r squared. And that's exactly what we've been asked to show. So finally, we're then asked to use calculus to make the surface area of a can a minimum. Well, let's start with our area again. It's 256 pi r to the minus 1 plus 2 pi r squared. Now, to find the minimum value of a surface area, we're going to have to differentiate the area. In other words, find dA. And because this is all written in terms of r, we're differentiating with respect to r. Now, because of the way we've written this, it should make it easier to differentiate. Multiply through by the power, minus 256 pi, that's all a number term, and reduce the power by 1, to the power of negative 2. Same thing over here, multiply through by the power, that's 4 pi, reduce the power by 1, we get 4 pi r. Now, at the minimum point, our differential dA by dr should equal 0. Whenever we find a minimum or maximum value, the differential is the gradient and it will be 0. So I can put that minus 256 pi r to the minus 2 plus 4 pi r equals 0. Now, this is something we're maybe not familiar with. let's rewrite it, and I'm going to take it to the other side as well, because this is negative at the minute. So 4 pi r is equal to 256 pi over r squared. The negative 2 just applies to the r, so that puts it over r squared. And now to get rid of that fraction, we multiply through by r squared. So we get 4 pi r cubed is equal to 256 pi. Or r cubed is equal to 256 pi divided by 4 pi. Again, pi's cancel. 4 goes into 256 64 times. So r cubed equals 64. R is equal to the cube root of 64. Now again, this is a non-calculator paper. They're not going to pick a really difficult value for this. Cube root of 64 is 4. So the radius is 4 centimeters. Now, we're not quite finished yet, because we're just assuming that makes it a minimum. What we want to do is show that it's a minimum, not a maximum. How do we do that? Well, we take our dA by dr and we differentiate it again. So we get d squared a by dr squared is equal to, so when we differentiate this, minus 2 times 256 is 512. We've got the pi, and reduce the power by 1. When I differentiate 4 pi r, I just get 4 pi. And at r equals 4, our second differential, d squared a by dr squared, is equal to a positive value, because this is 512 pi over r cubed, which is a positive value. 4 pi is a positive value. When we add them together, we get a positive value. A positive second differential implies something good. It's a happy face. You're positive, which is a minimum point. So we have the minimum value, or the minimum surface area, when r equals 4.